Okay, hello, welcome. Hopefully I fixed the sound this week. I realized that because I put this camera at the side using my phone because it makes me look more beautiful. If you're wondering why I've been looking more beautiful, it's because of this new camera. But I put it next to the microphone, so when I'm talking this way it's much louder, which I realized was clipping very badly. But hopefully I've turned it down now and it's better. But when I turn towards the computer and start typing, it won't be too quiet. Okay then, today I'm going to continue with the Untitled Code stuff. We're in day 9 now, so I haven't looked at it yet, but yeah, I'll open it in a second and we'll take a look, and then I'll try and implement it in the next hour or so. My timings have been a bit variable. Some of them have been very quick, some of them have been very long. Hopefully today's is not too bad, because it'd be good to get it all done in one session in the streaming. And it's also been a fun adventure in learning Haskell, or learning how much I don't know about Haskell. The one from yesterday was quite fun. Part of the one from yesterday was quite fun. A lot of it was very annoying. But at some point I thought, oh, this is kind of like parsec or some kind of parser combinator, except it wouldn't be a parser combinator, it'd be some kind of filter combinator. And then I thought, well, I read an article about how to implement that using an applicative functor, and I thought I'll do that. And then I realized I don't actually understand what an applicative functor is, and I went horribly wrong. And a lot of them have had that kind of theme where I think, oh, I'll solve it like this, and then realize I don't know what I'm doing. So hopefully today won't be one of those, but we'll find out. Okay, so let's take a look at the exercise for today, or the challenge for today. All right, it's shorter than yesterday, that's good. Okay, so the caves seem to be lava tubes. Oh, it's the vents again. Okay, if you can model out as smoke flows, you might be able to avoid it. Summary generates a height map of the floor of nearby caves. Smoke flows to the lowest point of the area it's in. Okay, so it flows to 0, but also to 1. I don't understand what the area is. Each number corresponds to the height of a particular location, where 9 is the highest. And 0 is the lowest. The low points are lower than any adjacent. Oh, so, okay, so looking at the square around this. So taking the sort of 4x4 square here, that's the lowest point. Same thing here, there's the 9s. If you take the whole, actually let's not do the 4x4 but the 3x3. So 7 is not lower than anything, than everything around it. Neither is 6, but 5 is. It's going to be a pain. Okay, so we need to go left and right, and up and down, and then diagonally as well, or not? No, only 4 adjacent. I should read the thing. Okay, so the 4 adjacent points, left down, up, down, left, and right. So stuff on the corner has got 2 adjacent points, so it's only 1 and 1, and here it's 3 and 1. And then on the edge you've got 3, so you've got the one above, the one below, and the one left. Okay. Diagonal locations are not counted adjacent. That's going to make life a lot easier, but not, it's still going to be annoying. Okay, so in the first one, there's 4 low points. That makes sense. Everything else is next to something that's lower somehow. Okay. The risk level of a low point is 1 plus its height. Right, so just take these numbers and add 1 onto them. Okay, and then you add them all together. So find all of the low points on the height map, and then sum the risks up. Okay, so I'm going to grab the input. Can I remember the shortcut? No, that's not what I wanted to do. So here's code running. There's VS Code. Okay, cool. So all I've done so far is I've created just a main file to save a bit of time. It doesn't do anything yet. but I am going to create in here a file called example, and then just paste in the example that they gave us, so we can use that. Okay, so I presume, actually, let's take a quick look at, I really thought it was going to work. Let's take a quick look at the puzzle input. Okay, so it's lines of numbers, which are not separated by any separator. Okay. Right to here. Okay. So what can we do? We can look at so we can look at the column next to it as the column before it, unless position 0. And then we look at the same column of the row underneath, unless we're the last one. Okay, so I might treat the top, the bottom, the left and right as special cases. And then top left and top right, bottom left, bottom right as special cases as well. But everything else should be a case of look left, look right, look up. Oh shit, that's going to be annoying. And look down. Looking down is fine because typically I'm going to take this thing, I'm going to split it by lines, I think. Oops, wrong thing. I'm going to split by lines, and this gives me an array of strings, and each string is one of these rows. And then just look at it for a minute. And then when we're on a particular row at a particular position, we should be able to look left and right and down. That should be easy enough, but looking up is going to be a bit more difficult, because if you think about you want to say look and, or maybe neighbours, we'll call this neighbours, but in the British spelling, because U's are always helpful, we'd probably take a list of strings, which is our map, and we'll take an X post and a Y post. We'll just take a position. Oops. So the type of position is just going to be a pair of integers. Okay, so we'll take the current position and we will produce a list of integers. So we just look at a couple of cases. So if we look at a sort of happy case, no, I don't want a position like that, thinking about it. Because I don't want to have to walk through the whole list of lists every time. We're only going to take the X position, so the offset we are into the current row. But that's going to be a bit of a pain, so that's what I thought, but anyway, we'll come back to it in a minute. We can do something like, you can say, if we have rows beneath us, then what we can do is we can say, so X is the current row, and then we can take the thing at the, oops, our position. We shouldn't call it X actually, because I want to call this the X position. So I'm going to call this row and rows. So we can take the position of X minus 1, and we can add that onto, oops, thing at X plus 1. We can add that onto the thing at, what you can then do is take the head of X's, or the head of rows, which is the row underneath us, and then we could, oops, take the X position of that. Let me just make this string chart for now. Or that would be just a string. We'll worry about turning integers later on. So that gives us the thing to the left and to the right and then beneath, but it doesn't give you the thing above. So you could do something where you pass in the row above as a separate string, but probably thinking that's not going to be the best way of doing it. So let's go back to the puzzle again for a second. One thing I could do is I could start it in this position, like the top left, and I can take this row and then I can take this column. So I can kind of F-map all of the rows, pulling out the thing at this position 0. And then when we look at this next number, again, I'll pull out the top row, but I'll F-map all of the inputs to pull out the second column. Because then what we could do is we could have something which takes a string, which is the row that you're in, and another string, which is the column that you're in. And then that's everything you should need to build the output. Should we turn this into ints at some point? We'll worry about that later. Actually, I'm not going to do it yet. Okay, so what's the happy case of this? No. Okay, so the first one is a row. So that's okay, we can call this x and any other x's. Do you want that? No, we just call it x's. And the one next is y. We need your position. Now I will make this two-dimensional. So type position is pair of integers. And then we can call it x and y. Okay, so what we can now do, I think, we'll forget about the edge cases for a second. But what we can now do is we can pull out the previous x position. What do I think? So that's the previous x position, and we add on to it next position. And then we can add that on to the y's bang bang y minus 1. So we get the thing in the column above us, and we add that on to y's bang bang y plus 1. Okay, what are you upset about? Upset about the fact that that's not actually a list. We'll just add that on to the empty character. No, the empty list, sorry. Okay. What are we upset about now? Oh yes. Oh yes or no? No, wait, what's the problem? No instance of that arising from minus in the first argument of colon. Bracket these things up a bit. I'm going to rewrite them anyway. But done the brackets wrong. Let's do the brackets right. Just it can't differentiate between the x position of x's, subtract 1 from it, which is perfectly valid thing to do to character, versus the x minus 1 position of the x's, which is what I really mean. So I'll check the brackets in to clarify that. And it's being undone in blue because it doesn't like the code I've written, so I'll get to fix it for me in a minute. It'll say, why not use something? Use literal instead of that, just put it in the list. Yeah, I guess that's probably a good idea. Okay, and let's go back to the beginning of this, and then you should be able to say s colon return c comma escape space. Okay, so in a normal position, that should give you the things above, below, left, and right. Now we're going to have some issues where you don't have things above or below you. So we need to handle those cases properly. But if I just pull these things out into helpers, should I pull them into helpers or should I test this first? No, let's pull them into helpers. We can say left is going to take a string, which is the row you're working in. You know, I'm just going to create typos for these things as well, because I might change them to lists of integers away from lists of characters in a moment, but I also might not. But if I do this, it should make refactoring easier if I need to do it later. It also makes the type signature clearer, I think. Then here we can say that this is a row, and this is a column. We got position, and it's going to return a string. We don't know what we're going to return yet. Okay, so left will take a row. It will take an x position, not an x position, but a position of x, and it will return the thing to the left of you. But this is going to be maybe, isn't it? So because the left of row and x, no, we know exactly what it says. So if it's a 0, you can't move left from 0. So that's going to be nothing. Whereas the left of r and x is r, oops, bang, nope. And then we can do our x minus 1. It's also just that. Okay, so we're going to fill up this list with maybe types. And then there should be a thing we can do to remove the nothings, I think. And then we can just make sure that none of those values are lower than the current value. We probably do want these as integers because we're going to sum them up later. But maybe for now we can worry about that later. A lot of the time you can get away with just treating them as meaningless tokens. Let me just copy that, it's going to be quicker. And then just at the last minute you can turn them into an integer if you need to add something to it, or subtract, or sum them up. Okay, so right. Exactly the same thing, but it's actually plus. Okay, and then we can this is not r of 0. This one's slightly more complicated. Not terribly complicated, but I'm going to use a guard for this. So I'm going to say if the so x is greater than or equal to the length of r, then we get nothing if we try and go right. Otherwise, and then should do that. I don't need the bracket. Okay. Okay, and then we should be able to do up and down. So I might rename this to before and after. But not with a capital B because it's not a type. I should rename them all. So before is that, and then this one I can rename as after because it doesn't actually matter whether it's a row or a column. That's annoying. Okay. So here we can rename this to row and column. And then the first element in this is before X. And this is after X. And this is before Y, and then after Y. And it's upset because these are all maybe strings. I told it it's a string. Now I'm just going to list it maybe jars to see if this works. What's this problem? Oh, sorry, before row of X, after row of X, or column of Y, and that, oops, after column of Y. Okay. So let's just check that does what I expect. This is day 9, GHCI, we pull in main. So our row, I'm just going to grab this from here. So our row is going to be this list of numbers. Oops. Let's do, yeah, let's do this one. Why not? So our row is that string, and our column is going to be harder to do. I can't do vertical selection, but let's pick. I can't do vertical selection. Actually, I've downloaded this data. Into example. Can't remember how to do vertical selection, but I can do. No, I thought I could do something like that. Grab that, and I select the beginning of the line, and then I say I, Shift I, no, Shift I. There we go. Okay, and I can do that. Then copy, no, undo that, yank that. I have no idea what's going to happen when I try and paste that. It did not do anything useful at all. It's also the wrong example file. And this is the example file I wanted. 98789, let's just remember that, it's easier. Okay, so 98789. Okay. We have a row and a column. And then we should be able to say, give me the neighbors of the row and the column. And then the position we're going to pass in is 1, 2, 3, 4, 5, and 0. So we get 9, which is to the left, 4, which is, oh, 3, it says. That's not right. Okay, something's gone wrong when we're going right. Something's gone wrong when we're going right. Oh, hang on a second. 1, 2, 3, 4, 5. There's actually 0, 1, 2, 3, 4, 5. I just can't count from 0. Okay, so we're actually sitting on the 4. So to the left of us is 9, to the right of us is 3, and then beneath us is, well, it should be 8, but I fucked up my extraction of the column. What we really want is that 9, 4, and 8. Okay, and nothing. So that's kind of cool. But if you call it at the top left, you get 1 and 8. 1, it's not really 8, but I just told it that's the only column it has. And if we were at the right hand side, so we've got here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be 9, 0. Oh no, 8, 0. Okay, I'm out by 1 when I'm trying to go to the very right hand side. That's not great. Let's go and fix that. So we actually need to be, if it's greater than or equal to the length of R minus 1, and the reason for that is because we're going to try and add 1 onto it. So if we're already at the very right hand edge, we can't add 1, and it's indexed from 0, not from 1. Okay, so let me just set up my row and my column again, and now if I try and get number 9, that's the correct answer, I think. So it's let's grab the example again. It's 0 because we're sitting on the 0 here. So to our left is 1, nothing to our right, nothing above us, and then it thinks it's 8 because I told it that this column contains the 8s. Okay. So that's cool. We can pull out our neighbors. We're not really that interested in neighbors. And the other thing I want to do is get rid of the maybes in the list. If I write this out in some naive way, I think that the language server will tell me the function I'm looking for. So we could say maybe nothing. That's not the function I want. What does maybe do? Maybe takes A to B and maybe A and returns a B. Okay, and from maybe takes, in this case, a list of characters, maybe a character, and returns a character. Okay. So from maybe takes I'm very confused now. From maybe takes a list of maybe characters. Turns out. Shall I import from maybe? Yeah, that might help. Okay. Now I can do that. I cannot do that. So from maybe we'll take maybe an A. Now it takes a value for A, maybe an A, in this case for characters, okay, and returns me an A. So if I take that and map it over my list of maybes, it doesn't seem happy, so what's the problem here? Oh, I can't do that. Did that, but that's not super useful. That's not really good. Okay, so let's do fmap. Just a second. It's going to be something in. I'll just look this up. No point in trying to guess it. Google. So we have a list of maybe A, and we want to go to list of A, cat maybes. It turns a list of all the gist values. So cat maybes is what I want, apparently. Okay. So here we can say cat. So cat maybe or cat maybes? Can't remember. Cool. We don't need it from maybe. We do want the cat. Okay. So now if I reload, define my R, define my C. So we called 90, we got just 1, nothing, nothing, just 8, and now we should just get 1, 8. Cool. Okay, so now let's improve this. So we're going to change this to a list of integers. And this is also a list of integers. This is going to turn maybe int. So it's going to turn maybe int, and it's going to return list of integers. Okay. Okay then, so what are we going to do with our input? So we have this list of lists, and we want to walk an entire row within that and get back all of that. Yeah, let's just get back all the neighbors first of all. So maybe let's do is, what was it called? Is lowest, is that what we're looking for? Is low point. This stream is a low point. So is low point is going to take list of strings. So this is our entire input. Let's at this point list of strings and a position. We have a type for that. So position, and it's going to give back a bool. Is that going to be good? Why would I want that? So I want to take each position, say it's a low point, then put it into the output. Otherwise, just keep going. So it's low point. So we got our x's and our x and our y. These are not x's, these are rows. So we want to take the current row, like the y value here. Actually, I'm just going to call, what I'm going to say, it's the lowest point if we need a value. We can get the value. Okay, so if the value at that point is lower than the minimum of the neighbors of the row, the column, and the position. It's going to capture this as well as destructuring it. Okay, so where the value, what are you going to do here? we got our rows. So if you say rows bang bang y, that gives us the current row that we're in. And then from that, we can then take the current position. So the current position is x. Okay, and I'm just going to call read on that because we're going to turn it back into an int. I think read will not work on that. Oh, that's really annoying. Okay, let's just make them ints. Let's make my life much easier. So what's wrong with this? Rows bang bang y couldn't match first type with actual type int. Yes, because it's a list of integers. Previously it's a list of strings, and strings are themselves a list of characters, and now we made it a list of integers. Okay, so that's value. Row is equal to, let's do this the other way around. So column is equal to rows bang bang y. I've just defined that above, so I'll replace it. And this is call bang bang x. No. The row is that. And the column is all of the rows at the x position but what we want to do is how do we fmap that? If we fmap that, we're going to get a list of individual rows. Okay. So we can do bang bang x over the rows. Oops. So I might just rewrite that as that because there's no point in leaving the code readable. Okay. So what we're going to do is we're going to look up our neighbors. We are going to find the lowest point in our neighbors. I'm going to say, are we lower than the lowest point in our neighbors? And if we are, then this is a low point. Okay, so let's reload that. And then what can we do? Can we say read file example? Example. I wonder if we can do this. Or something like. No, we cannot do that. We can do this. No, we can't. Don't call it in. Okay. Cool. So we have our example input. In fact, can we say apply lines to that? That's even better. Okay. And then what we can do is if we take the head of the example, so it's just the first row, can we fmap read over that? I don't think we can because those are characters, not strings. Can we say from integral? No. How can I turn this into, let's say this, I mean, this string representation of 2 into the number 2? You turn this into, I'm going to turn the digit into an int. Like if it was a string, I can call read on it, I cannot. Oh, I can. It just doesn't understand what I mean. Right. So can I do this where I say I want it to return a list of integers? Can it work out from that? No. Okay, so it's not going to read from something which is not a string. So if I then, instead of that, something, okay, so if I fmap over this, the function that takes a single character, it turns it back into a string, puts the head of x. Oops. Okay, and then can I read that? As an int. Yes. It's kind of ugly, but it will turn stuff into that. There's probably a way, like the ASCII code for 2, I could probably work out what that is. But I don't know the function for telling me that. Look it up. I've got the internet. ASCII code 2. 0 would be better, but maybe we'll start at 0. Where are we? 0 is 48. So we just subtract 48 from those. So if I say minus, I think that's about that. So minus 48 mapped over the head of x. Now, can I say 0 minus 48? I can't turn that into an int. Okay, forget about it. I'll use the thing that works. Then we can just get on with our lives. Okay. So, to solve this, we want a two ints. I'm just going to call this pars. I'm just going to take a list of strings and return a list of ints. Yeah, I think that's what we want. So x's is, and what do we have before? So we want to do that, but map this over the entire input. Go on to the hint. Okay, does that work? So let's reload that. We'll grab our x's again, which we do by reading from the input. Yep. Okay, and then we say pars x. And now we get a list of integers. Okay. Not the prettiest code, but it should work. So pull it back up again. So can we then say is low point? Oh, we need to save that, sorry. So input is that. And then we can say is low point, and it's going to take the input and then position, so we'll give it 0, 0, and it should say no. But 0, 1, no, sorry, 1, 0 should say yes. and then 2, 0 should say no, and 3, 0, and so on. I'll just pick another one that we know is a low point. So this is 3 in and 3 down. 2 in and 2 down because we index from 0. Okay, and 2, 3 is that. Okay. So then what are we going to do? We can start from we can go from sort of left to right. And then just visit every node, and if it's an endpoint, then we'll put it onto a list. So we parse our stuff. We want to say find low points. And it's going to take this list of ints, and it's going to return as a singular list of ints. And the way it's going to do that is it's going to say so we're going to map over all the x's, and inside that we're going to map over all the y's, and we're going to call his low point. So that's going to give us back a list of bools. So we could say, oh, this is annoying. I might write slightly longer form. So it's just in here I need access to both things. So this is actually going to give me the Y position. And then with that, is that right? No, it's going to give me the whole row. It doesn't give me the position at all. I want like an F map with index or something. I guess I'm not F mapping here, I'm folding, aren't I? The digits are 30, 31 to 39 in hex. That's pretty handy. I wonder how to do hex numbers in Haskell. Like, I think I can do 0x, whatever, but it's probably a language extension as well. Okay, I want to walk through a list of lists. So I actually want to walk through a row. Let's do walk row. And it's going to just take a list of integers. And it's going to take an x pos, which is an integer. No, sorry, a y pos, which is an integer. Is that right? Just trying to work out how to. This would be so easy in a, like I said, normal language, in imperative language. If I do, I'm going to go back to find low points. We'll take our list of int, and we will return. We'll take a position. And we will return a list of ints. And what I'm going to do is sort of recursively move through those positions. So the terminating for the whole termination thing for the whole thing is going to be this is the input, and then we have an x and a y. So I'll need a guard for this. So I'm going to say where x is equal to the length of the head of input, just any row, it doesn't matter which one, and y is equal to the length of input, so that's a number of rows. So if we have that, then we return nothing, right? We're done, there's nothing left to do. Otherwise, if x is equal to the length of the head of the input, then we're at the end of a row. Does that make sense? Yeah. So we actually step beyond the end of the row, in which case we're going to say find low points. It's not going to be super efficient, but who cares? Input, and then it'll be 0 and y plus 1. Otherwise, and now we can say if is low point and put this in the card, because why not, eh? So if input and position, I need to remember position. Okay, so if the current position is a low point, then it's going to be value added on to find low points input x plus 1 and y. Otherwise, it is going to be find low points of input x plus 1 and y. Okay, so value is this thing where we say take the input and find the y and then find the x of that. Okay, so I can tie this up a bit, but I just wonder if it works. So in theory to solve this, right, we just say if we parse a string and then we get a list of int to ints, and then we find low points, and I'm just going to show that. Now instance for show position to int. Oh, I've missed. So find low points, we're going to start at 0, 0. I'm going to swap these around just to annoy myself. So take position. No, I don't want to do that. We can do this. Parse, oops, x's, and this is no longer a partially applied function, so we can say that. Okay, so I just run it. Oh, we fall off the end of our list. So 1055, does that match what they had? Yes, 1055. I need to worry about this falling off the end of the list thing. And then, oh, I'm up by 1 and checking my y's, I think. I'll double check that in a second, but I probably forgot to index from 0. Then we want to count them up, and then we want to or we want to add 1 to them and then count them up. Okay, so if x is equal to the length of this -1 and y is equal to the length of input -1, then we stop. Is that right? No. Weirdly, it's that. It's because when we're recursing, we've already added 1 onto x without checking to see whether or not we fall off the end. So we will fall off the end. We'll come back into here and we'll say, are we on the last row, which is y equals this thing? If we are, have we fallen off the end of it? And if we have fallen off the end of it, stop. Okay, so that fixes that. Now we have find low points, and we want to add 1 onto those. Which is 2166, which is what it's looking for. 66, and then we sum them up. $15, which is cool. Okay, so we put in input. I haven't stored input, so I'll grab that now. I wonder if we can take these up a bit. Sorry. I mean, I wonder if we just pass in the number of rows and the number of columns. So this is all our input. This is the number of rows. And this is the number of columns, and then the current position. So this is going to be rows, going to be columns. So that it's equal to rows. It's not rows, is it? It's call it row lengths and col lengths to stop confusing myself. So this is row length, and this is col length. This is row length. Okay, and when we're recursing, we need to pass in these things. We'll pass in row lengths and col lengths. And same thing here. Oops. And same thing here. Okay, so when we're calling this, we parse the x's. Let's just call this input for a second. Got to say where. Where input is equal to parse x's and row length is the length of head of the input. And col length is the length of the input, the number of things it has. And then here we pass in the misspelled row length, which I'll go and fix in seconds. And col length. Okay, just check that still works. Yep, looks okay. So I'm going to create a new file called input. Running out of time. I'm not sure how difficult part 2 is going to be. So copy that back to here, paste it in there, save it, and run input. Hope it isn't too slow. 462. Where are we? So 462. Okay. So part 2, please don't be bad. Need to find the largest basin, single errors and most important to avoid. So the basin is in all locations eventually flow downwards to a single low point. Every low point has a basin, or some basins are very small. Locations of height 9 do not count as being in any basin. Other locations are exactly one basin. Okay, so basically we find our low point and we walk left, right, up and down until we hit a 9. Or we run out of input. Okay. And the size of the basin is the number of points within it. So it's not the value of this. And then it says find the 3 largest basins and multiply their size together, just to be annoying with this. Okay. So part 2. I'll take our list of integers, list of strings again. We don't actually need a list of strings, let's always just pass a list of ints. Just show for a second. Okay. No, I didn't do that. So if I grab, no, if I grab that, hit star and then that, and then no, I don't know how to undo that. Okay, I'll just rename it by hand, it's easier. No, it's input. Oh, we don't need to parse input anymore. Okay. I'm just going to check I haven't broken it. That's cool, I haven't. Okay, so what do? We conveniently have this thing which will find low points or identify low points. And then from there, it's just a lot of walking, isn't it? So find basins. Let's do a single basin. Okay, so we have our entire map of everything. And we're going to be given the low point. And then we want to return. I guess initially we could just return all of the numbers that are in the basin. We don't really want the numbers in there, we just want to find basin size, I think. Okay, so this is going to be basin size left plus basin size right plus basin size up basin size down. Okay, so basin size up. I'm going to apply input to all of these. So basin size left. Yeah, I'm just going to pass input into all of these and pull them out to their own function because they're going to be a little bit long, a few lines, but that's long for me. Okay, so basin size left. You're going to give them a map. We also have the position, so we can say just destructure that into X and Y. And we don't want the whole input, do we? We just want the row. So the row is rows bang bang Y. And the column is the X position of all rows. Okay, so we're going to list of integers and the position. And we want to count. Okay, so basin size left. And what are we going to do? What we could do is, here's naively, right? I could say if there's nothing to the left, just want to actually only take X things because there's no point. We don't want anything after the X. So we say take X in the row. And now we don't need the X position. You don't need to know where you started. You need to know everything that's to the left. So there's nothing to the left. It's 0. Now it gets more difficult. So we want to say that if the last thing is a 9, so I think there's this, you can partition something up, I think, with data.list. I'm just going to go and look it up. It's going to get a little bit, I'm running over a bit. List. Have a look at these things. So there's a, no, it's sublists, I think. So take and drop we want. Split out is not the one I want because it splits position. I want span in terms of tuple. The first element's the longest prefix. I kind of want, trouble is it's, I was going to say the trouble is it's starting from the left. No, sorry, we're starting from the right here. So if our, given this input list, we would actually be here. We want to work this way, but we just reverse it. So Basin side, we're moving in a single direction here, but actually what we can do of x's is, was it span? Span less than 9. Oh, maybe break is better. Break less than 9. No. Strip prefix, no. Group, no. Let me choose span. It'll get the job done even if it's not the best thing. So we say span less than 9 x's. And then we want the length of the head of that. Not the head, because it's a pair, a tuple. Why not use take while? Okay. Why not use take while? How does that work? Take while less than 9. I'll look at an example just here. Okay. Thanks, Lightning server. So let me just rewrite the whole thing. It's the length of take while less than 9. Okay, so basin size left is actually basin size oops. Let's give it some extra arguments. So we'll give it the whole map. No, we'll give it a row. But we'll give it the X position. Because then we can say business left is the basin size up to reverse. I need some arguments here. Let's not do that. Of the thing passed in. So we're going to take the first X elements, and then to go take the left thing, we just reverse it, and we call basin size on it. So we could probably just not bother with lots of functions. Basin size of the reverse of this. And then basin size. And here we're going to say, we don't need to reverse it, but we're going to drop. I think it's X. I think neither of these will return X. It's always things up to that point and things after that point. Okay, so then up is take, I'm going to reverse this, take Y from the column, and then down is drop Y from the column. Okay, so that, given a single point, that should find the size of the basin around it, I think. So how does this solve work? So first we can say, I'm going to say show, I guess, and we can say find basins, which we don't have yet. of the input, and it will need some starting position, I guess. Oh, you might as well give it the row length and the column length again. Okay, so now it's about to find basins, which is a bit like find low points, I guess. Okay, so if we're in the last position we don't get anything, if we're at the end of a row, not that one, shift, start and shift N. This is find basins. Okay, so at the end of a row we look and we start again from the next row. If we have a low point, then what we want to do, we have our X and Y positions, so we should be able to say find basin size, the input, and then the position we have. So if we're at a low point, we find the basin size, and then we add this to our list of things we're returning, and then we recurse moving along one, otherwise we just move along one. Okay, I should really pull these out into some variable, but I'm not going to. Okay, in theory I should walk through and find things. I'll tell this to run solve 2 instead. Checking the example, 3, 8, and 7, that we're out by 1, I think. 3, 9, 9. Oh, they got 14 we didn't get. Oh, this is harder than I thought. So it's the 5 which is the low point. Oh, that's really annoying. Okay, so for each place we visit, we also need to move in all directions from there to be hit at 9 as well. Because the 5 here, it goes down to the 6, I guess, but the 6 goes out both directions, and every point in there will also go out. Okay, so I need to treat all of these like they are low points in themselves. And we're also out by 1 because I'm not counting the low point itself. So out by 1 is easy to fix. That's 1 plus that. Okay, but the basin size is more difficult, so that's going to be quite tricky. So we can't. It's always when I'm finding these things, I'm not counting the I'm not tracking the position at all, which I think I might start needing to do. Okay. So we got position. I want to start passing it in here. So this is our input, and we'll pass some position at the end. Oops. And here we will pass in a position. Okay. Oh, we haven't got the whole input either. So this is not the full basin size, it's the basin size in one direction. How are we going to do this? So if we have the full input, and a position, so give me a second. If I just move my where up for a second and give these things names, we can say left is equal to this, right is equal to that. Up is this, and down is this. And then it's going to be left plus right plus up plus down. This goes back to be called basin size. And then we can have something like expand basin. And we'll give it the full map. The starting position. These list of lengths. So we got left, right, up and down. And what's this going to give us back? Another integer. So we've got our input, we've got our position, we got our left, we got our right, up and or down. And here we want to sort of go left one and then find the basin size from that point. So we want to apply find basin size, which takes an int, not the int, sorry, it takes the input and it takes a position. So we're actually going to map it over pos minus left up to pos, except it's not pos, it's actually x. Okay. So it's, is that right? We don't want it to walk left and right at that point, but we only want it to walk up and down. We're going to say walk up. Ooh, doing that. Try Alt. So walk up, what are we going to do? We're not going to... Oh, goodness. We're not going to find the basin sides, we're just going to do the up and down thing. So here we can say basin size. So we're going to walk all the way left, going up as much as possible. Oh, this is really tricky. Start here. We know we can go this way and up and down. So we need to expand up. It's going to go to 8, and then we find the basin size from that. The trouble with finding the basin size from that is it's going to find this stuff as well. So we want to forbid it from going down. It can go left and right. But we want to forbid it from going up as well, I think. So if we've gone up to this one, we can go left and right. If we go down, we can go left and right. But as we go left and right, then we also want to allow these things to go. They can't go up and down either. Okay, what I might do is, rather than counting things up, find all the positions and then unique them, and then count those up. It's probably the easiest thing to do, is just let it explode in all directions. Is that true? And maybe the down is okay, so we let it go. If we start here, we've gone left, right, up and down, so we go down 1, we let it go left and right, and as we go left, we let it go down as well. And as we go down, we can go left and right, and as we go left and right, we can go down. Oh, this is horrible. I wonder if it is easier to just find the positions. I don't know. So just looking at going down, so we don't want the full map, we just want the lower rows, so that the stuff that comes after, so we'll drop Y, whatever input. Okay, so it'd be, if we're going down, we could say that plus expand down, and then it's going to be drop Y from the input, and then our position. What we want to do from here is, towards it going left and right, there's no guarantee we haven't visited that thing already. So the thing I'm worried about is that we don't want to double visit any point. What are we doing? We're running way over time here. can't easily modify it to pull those things out. I don't think I could keep a map of things I've visited, I guess. So we just have a list of positions. So if we've already visited this position, how do we know? How do you know whether or not we've been there? Like if you go in just left and right, how do you know whether or not you've already visited that? Oh, I'm just not working this out at all. It's the most tricky case. So you're going down, then you're going across, then you're going down. What you could maybe do, I wonder if you could just cut a square out. No, it doesn't work either. Because you don't want to just count all the non-9s in that square. It feels like we need to somehow track where we visited before, but that doesn't seem like a trivial thing to do. Because we're not really visiting and we're just kind of walking left. As we walk left, we could remember where we've been. So it could return So here we could say visited left is so we can go from x minus left up to x. Okay, what's the good way of writing that? Why not use what? Why not use comma y may require a language extension? I guess so. Why not? No, I'm going to ignore that. I think that will help me. Okay, so we now know a list of positions that we visited by going left. And similar thing here, so we can say AY, and we're going to apply this to X, X up to X plus right. And then visited up is A to X comma A, and visit up will go from the lowest thing we're going to have is Y minus up. It's going to go up to Y, and visited down is x comma a, and this is going to be applied to y up to y plus down. Why plus down? Oh, because I'm starting at the top of the thing and going down. Okay. Let me see if I can get it to shut up because it's a bit annoying. I'm not sure that's any better, but at least it'll stop the hints. Okay. Okay, so I put this in, so we're going to track a list of positions that we've been to. And I'm going to stick a garden here. So first of all, we're going to say if position is an element of visited, then we're just going to turn 0. Right, we're not going to visit anything else. With nothing to add. Otherwise, I've got these right around. Okay. So we're going to take our different directions. Is there a recursive call? Yeah. Find Basin size, blah, blah, blah. And we'll just seal it with an empty list of visited. Okay. So what we now want to do is do that. And then we're going to say explode Basin. And what's this going to take? This is going to take the input, the position. This is the one that's going to take everything up, down, and also the visited. Wow, a lot of stuff. Okay, how do we explode a basin? I'm just wondering if visited will thread through all these calls and if it will build up, or if we ever would call it with just a partial set. I guess we'll find out. So explode basin, what's it take here? It takes the full map. It takes the position, takes the number of things we go left, the number of things we go right, the number of things we go up, the number of things we go down. And the position, list of positions, the visited list. Yes, it returns an int. Okay. So input position at x, y, then left, right, up and down, and then visited. So we can explode left, I think. By saying fmap find basin size do an fmap. Maybe because I think we want to get the position out again at the end. So from that, we're going to give it the input. We need to give it position. A for a second. And then we need to give it visited. This is not great. So I was going to do it from these up and down should be internet. I was going to do it from x minus left to x. Well, if we just give it a visitors map and it goes to every point in the visitors map and explodes from there, apart from the position that we started from. No, because that would recurse forever. Because you keep going back and forth. I've had another thought. I'm not sure it's going to work or not. We start at position 5 and we know what's left and right and up and down. So can we go up? Like assuming we have something above us, can we go up and then explode from here? Doesn't work either. Oh god damn it. My visit stuff is not working well. I could do it statefully, I guess. I could use a state monad. I just keep passing this list of positions in. That might be one way. And then if we have the same position, then we stop. Would that work though? I don't know if that would work or not. I think if we go up and we reduce the input to just these rows, then we can take this position 8 and explode from there. But you need to keep doing that. So if we went up, then we would take this row. If we didn't go up, we wouldn't. Then we go left and explode that way. And then we would go right and explode that way. So we take the next digit, which is 7. Because we're going right, we cut it down to just this stuff. No. This is really tricky. Someone got any bright ideas before I give up? I feel like I'm missing an obvious solution again. I can't see what it is. it's just this kind of, you can go down and you can sort of search left and right from here, which is fine. But the new things that you pick up, do we know what's genuinely new? So if we go down and go left and right, if you go down and left, we know we haven't visited that before because you can't go diagonally. We know that you can't go up, so I'm just going to drop out all this stuff. So as you go left, you want to drop out. Do you want to drop out anything? I can't drop out this number. 2 pieces of state, a queue of positions and a list of visited positions, as well as a list of positions with the answer. So I'm putting each low point in all 3. So when you did it with the state to track visited positions, did you do it in Haskell or did you do it in a language which let you mutate that list and pass a reference to that list around? Because the trouble I'm having with the list of visited positions is that I can't update it. Yeah. So did you mutate the list as you went? Because keeping track of the positions is the thing I'm struggling with here. Yeah, it must update it. Okay. So okay, we're doing this, but import control mode state. And the state is going to be a list of positions. So we're going to give it a map, we're going to give it this. What's the type of state again? Star, star, star. Parameters with type S of the state to carry. Yeah, okay. This is not the time to start it. I think I've gone as far as I want to for now. I might come back to this tomorrow and see if I can finish it with some state stuff. But yeah, I think that the difficulty here is in keeping track of the stuff that we're updating as we go. And what I was starting to think was I could actually return a pair of int, which is the thing we're interested in, like the count, but maybe just return a new position. Like all we're interested in doing is putting stuff into the position. And like you said, just get to the end and count the number of things in there. But yeah, I'm not going to start that refactor now. And this position just makes me think it's a state monad. And then you can just say set with the new positions in it. But yeah, I'm not going to do that now. So I'm going to give up on this one and then come back to it maybe tomorrow, maybe the weekend, and finish it off. I think bit of an annoying one today, particularly for part 2. Part 1 was okay, I think. Just took me a little while, but part 2 was I hit Haskell again. This happens occasionally with some challenges where just using Haskell makes it more difficult. Okay, cool. Thanks for watching along, and thanks for the hints as we went. Yeah, next week I'm back again, so we'll do day 16. I guess it will be by then. Hopefully it'll be a better fit, but we'll see what happens. But yeah, thank you for watching, and hopefully see you next week. Goodbye.